The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
Welcome back to another episode of Titans of Nuclear. I'm Hannah, and today I am joined by Natalie Cannon, a PhD student at the Georgia Institute of Technology and an advanced nuclear technology graduate research assistant at Los Alamos National Lab. Natalie is a part of our newest series highlighting young, influential leaders in the nuclear energy industry. And Natalie, welcome to Titans of Nuclear. Thanks for joining us.
Thank you so much for having me on. I've been a huge fan of Titans of Nuclear for a long time, so it's such an honor to be here.
Well, we're really excited to learn more about you today. So just to kick things off, why don't you tell us a little bit about yourself? Kind of, where'd you grow up?
Yeah, so I'm from Anaheim, California. So I grew up basically 5 minutes away from Disneyland. So I grew up going to Disneyland all the time. Lived in California my whole life, went to undergraduate there, and then decided when I was going to grad school that I was going to make this big change and move across the country and go to Georgia Tech. And now that's where I am now.
That's so exciting. And how were you originally introduced to nuclear energy? Was there a moment when you realized that this is a field you wanted to get into?
Yeah, so my path to STEM in general and to nuclear is not typical. So I started at a community college, and the reason I went to a community college is because all throughout high school I wasn't great at math and science. I would get C's, B's. I wasn't like a stellar student. I wasn't taking physics. I didn't even take math my senior year of high school. I thought I was going to go into film, and was in this great film program in school, and was just like, yeah, I like it. I've always really loved science, but I just don't have the aptitude towards it. And so I just figured that's what my career path was going to lie. And then woke up one day, like 2 weeks before I was set to go to college, and was like, I don't want to do this. Like, I want to, this is my one life. Like, I really want to try to do STEM. So I went to a community college, changed my major, I think 4 times, from computer science to mechanical engineering to aerospace engineering. And then finally my undergraduate degree is in physics. And kind of just fell in love with physics because I got involved in internships. And as a community college student, there is no internships for students, but there was one through the Department of Energy. And I went to Princeton Plaza Physics Laboratory, which specializes in nuclear fusion research. So I spent 2 summers there working on a fusion rocket engine, the PFRC, the Princeton Field Reverse Configuration Reactor, and loved everything. And while I was there, I got involved in science policy, specifically like nuclear science policy through the Federation of American Scientists. And that was something that when I was deciding where I was going to go to grad school, I was choosing between plasma physics or nuclear. And I decided to do half and half nuclear engineering and then half plasma physics applications. And I got into Georgia Tech, which has been my dream school for years and years. And for nuclear engineering, I was like, this is a sign, I'm going to do it. And didn't do fusion, ended up going into fission, which is something that I was not familiar with at all, and just have been doing this for 2.5 years and just absolutely love where I am now.
That's amazing. And this current work that you're doing, can you kind of elaborate on your thesis and what you're trying to investigate?
Yeah, so my master's thesis was more policy-based than technical-based, which is something that I was really interested in. I'm very interested in international and domestic science policy. So my particular project was looking at additive manufacturing, so 3D printing, and the role that it plays in the nuclear technology industry. So how can we use it in reactors? How can we use it in detectors? And what's the future of additive manufacturing for this, for the industry? and then seeing at what current policy, both international and domestic policy, are saying about how to regulate it. Because while this is really exciting and amazing, we want to kind of foster this growth, we also don't want to get it into the wrong hands. And so a lot of what I was doing was developing regulatory frameworks for additive manufactured nuclear technology for international and domestic export control regimes. So that's what my master's thesis was in. Now I'm kind of pivoting. I work with Los Alamos now for my PhD work, and it's very different, but I love it.
Yeah. Can you share, just off the top of your head, any particular policies that you or frameworks that you put together that you could summarize relatively quickly?
Yeah, so let's look at like the Weisenar arrangement. So the Weisenar arrangement is an international export control, and it's largely based on materials. And currently, in international export control regimes, there is really no literature about additive manufacturing. If there is, it's basically what we took from subtractive manufacturing or very traditional manufacturing techniques and changed a few words so it would fit, quote unquote, to additive manufacturing. So looking at like the Weisenar arrangement, we can look at the very specific like metal deposition additive manufacturing technology that we're currently using to manufacture reactor components and work with like legislators and the additive manufacturing industry to develop basically policy to not like stifle the industry, but make sure that it doesn't get into the wrong hands. So we haven't written any sort of policy yet. This is more just a framework that we can then take to policymakers and be like, okay, this is how we should rank all the different additive manufacturing techniques that are currently being used, how they apply to the nuclear industry, and then from there, write something based on that. So I'm not informing policy, of course, I'm just a nuclear engineer, but yeah, that's basically what that's doing.
Just a nuclear engineer. What about conventional manufacturing techniques means that it's not really a good fit to kind of transfer those policies over and try to apply them to additive manufacturing?
So looking at conventional manufacturing techniques, it's mainly subtractive manufacturing. So you have like a sheet of metal, as a very basic, you have a sheet of metal and then you're taking off pieces of it that you don't need, and that's how you get your final product. Or you're welding stuff to different pieces together, and that's how you get your final product. Additive manufacturing is a completely different approach. So you're starting from the ground up and you're using just the amount of material that you need to build it up layer by layer. And so you can get these really complex geometries that would be almost impossible to do with traditional manufacturing techniques. And because you can get these really interesting and complex geometries, you can also you just can't apply the same sort of logic to it, and that's what makes additive manufacturing a little bit more complicated than looking at traditional manufacturing.
Okay. And this may be an oversimplification, but do you think additive manufacturing just makes it significantly easier to make the parts that you need for various nuclear applications? Do we need stronger controls on this than we might for subtractive?
Yes, I think we definitely need stronger controls. However, I think that there is this kind of school of thought. It's called almost Fortress America, and it's this, additive manufacturing is the military has interest in it, and so a lot of times, a lot of military leaders want to kind of have pretty strict regulations, but we don't want to do that because it's going to stifle the industry. And something that we need to remember is that a lot of the literature about what we should do about additive manufacturing from the U.S. perspective kind of assumes that the United States has a monopoly on additive manufacturing technology and development, which is just not true. The bulk of development takes place in Europe and like France. And I think it needs to be sort of an international conversation about creating policy and regulations that's going to protect us from proliferation incidents while not making it so that it becomes a militarized technology.
That makes sense. And if you don't mind my asking, does this master's, did it connect to your undergraduate physics work in any way, or did you kind of decide you wanted to try something kind of a science adjacent for a little while?
It was completely different. So yeah, my undergraduate work was very much plasma physics. So that's what my degree is in. And the research that I did during undergraduate was looking at like helium permeation through membranes
Okay.
for this fusion reactor. So it
Mhm.
was very like fundamental physics. And when I went to grad school, I'm advised by Dr. Bogowski and Dr. Erickson,
Mhm.
and I mentioned that I was interested in policy, and they mentioned they had this project that they needed someone to work on, and I was like, yes, I want to get all really in depth into all the policies. I love reading policy memos and like the CTBT, all the
Mhm.
treaties. So I was like, this is the perfect kind of introduction to nuclear engineering, because I also came in with very little knowledge of like the fundamentals of, not the fundamentals, but like the in-depth uh, like knowledge of nuclear engineering. There's a lot, like physics is great, but I don't have a degree in nuclear engineering going in.
Right.
So it was a good way of kind of transition into um, nuclear engineering field.
Yeah.
Yeah.
Cool. Cool. And you just mentioned that you have a couple of mentors. How did you find them? How did you develop those relationships?
So I think a lot of students, when they're going through the graduate application process, it's just like you basically spend 6 months Googling people and stalking them on LinkedIn until you find the people that are the right match.
Mhm.
So I had actually was originally intending to work with another professor here who actually had retired, and I did not know that. And when I got into Georgia Tech, I was like, well, he's gone, but I'm still really interested in nuclear engineering, and this might actually be a sign that I should pivot and look at fission. And so I found Dr. Erickson lab, which is the Laboratory for Advanced Nuclear Nonproliferation Studies. And nonproliferation is what I did. The bulk of my policy advocacy was on nuclear nonproliferation, and so I was interested in learning more about the technical aspects of it. So I asked if I could meet her. She was confused at first because I was a fusion person, and she was like, "Why are you okay?" But she agreed to meet with me, and we had a great conversation. Dr. Bogowski, who is the department head, was also on that meeting, and kind of walked away. And a few days later, they were like, "Do you want to be co-mentored by us?" And I was like, "Yes." And I'm a very lucky graduate student. I have two amazing mentors. But yeah, that's kind of how I
Cool.
got here.
Cool. And besides handing you this amazing science policy project to look into, what have you gotten from that mentorship? How has it been valuable for you?
Yeah, so Dr. Erickson and Dr. Bogowski are two very well connected people within the nuclear industry. And so being under their guidance has kind of allowed me to see the entire scope of what I could do with my degree. And they're also incredibly knowledgeable. In my opinion, two of the best nuclear engineers out there. And just being able to have a conversation with them where you can talk about, or I can talk about my research, or just listening to them talk to another graduate student about their research, you always walk away learning something.
Mhm.
And despite the fact that they are really these titans of nuclear, not to say the
Very nice,
title,
very nice.
they're very down to earth, and
Mhm.
they are dedicated to their students. So they're going to put their students first. And it's it, it's been a great way to kind of go through grad school, because I know that they have my best interest, and that I'm going to be a good nuclear engineer because of their guidance.
Mhm. Yeah. Um, can you name off the top of your head any pieces of advice that they've given you during your kind of mentorship period that you think might be helpful for?
Yeah, they were. Dr. Bogowski is really big on me doing like internships. So basically, seeing what you don't like doing before you choose what you do like doing,
Mhm.
and not being afraid of trying stuff within reason. I think a lot of people are like, "Oh, just try stuff. What's the worst that can happen?" In nuclear, quite a bit could happen.
Yes.
So kind of taking a logical approach and stepping back, and just before you do anything, just being like, "Okay, is this actually going to help me in any way?" And that's something I'm always someone that's like very quick to do stuff, and of like making sure that everything's done on time. And they're like, "Okay, it's fine. Take a step back, recognize what might be some of the flaws in your logic, and then proceed." And
Mm.
that has been something that has really helped me as I've kind of gone through grad school.
Yeah. Have there been any particular points in the research process where you've really needed to call that to mind?
Yeah, when I was writing my master's thesis, most master's theses are, at least at Georgia Tech, are 50 pages.
Sure.
Mine was 125.
Oh, wow.
And I was just putting every single thing I possibly could, and like the background of like what the policies that I was referencing was just way too long.
Mhm.
And I was like just putting so much information into it. And I remember having a conversation with Dr. Legowski, and he was like, "Yeah, you just like it's good. You just need like you just need to not go so intense." Because he was like, "You need to recognize what the scope of this project is, and you're trying to encompass every single thing, but you really realize that you're kind of focusing on one really small portion. And so it's important to get the depth rather than the breadth of it."
Mm.
And I that was really helpful to me when writing, because I think I could have gone like 300 pages.
Yeah.
And he kind of was like, "Okay, you need to stop," and helped reel me back in.
Yeah. There's a lot to say about additive manufacturing for sure.
Yeah, there really
Um,
is. Yeah.
No, it sounds like a very cool field. I have one more kind of personal question, and then I actually do want to dive back into some of the research because we only got partway through that. But what does a day of research look like for you now? And maybe how is that different from when you were doing your master's, and they're different topics, obviously, but.
Yes. So when I was a master's student, they wanted me to focus largely on classes.
Mm.
And so it was basically get in around 9. I'm not an early riser, so I always get in around 9. And typically I would start by reading papers that had recently come out. And I am someone that has to read papers multiple times before I actually really understand them and annotate. And after that, I would head to class. After class, I would be so done with that class that I would just go back and sit and kind of look at what I needed to accomplish for that week. And so when I was writing my master's thesis and when I was researching, I gave myself a very strict timeline because, this was a very policy focused, so I'm not running experiments in a lab. And so I needed to give myself little like milestones that I was like needed to meet. And so I'd make sure I was meeting those milestones. Having 2 advisors means that I have 2 lab meetings every week. So
Mhm.
normally I'd be in a lab meeting for an hour or 2, just going over what I did, listening to what everyone else is doing, see if I could give feedback, or just learning from what other people are doing and see if that would help me in my future PhD work. Then probably another class, and just basically spending the day writing and writing policy memos, either for my advisors or just for myself for future reference, and a lot of reading. So a lot of reading for this master's thesis. Nowadays, so my PhD research is through Los Alamos National Laboratory, specifically with the NEN2, which is the Advanced Nuclear Technology Division. And so I'm kind of splitting my time between Los Alamos and Georgia Tech because I still want to contribute to the research that's going on here within the lab. But I have obligations because they're like paying me to Los Alamos. And so I went to Los Alamos this past summer. I worked 40 hours a week and I just did a bunch of little projects that kind of encompassed everything that the NEN2 criticality experiments division did. And nowadays, I typically get in, I'm working on a bunch of MCMP codes for this experiment that we'll be doing at the Nevada National Security Site in 2024. I don't know when. And getting frustrated at the code because I am not a programmer, and then asking my lab mates for help. And then I'm also getting more experimental hands-on work. So I'm doing a lot of neutron noise work for my PhD. And we have quite a few neutron sources here at Georgia Tech. So I'm getting trained on how to use those and kind of developing some like preliminary experiments that I could do that could help my research down the line.
Interesting. For those of our audience who don't know, can you explain neutron noise?
Yeah, so neutrons are weird. That is the one thing you need to know about neutrons, if you know anything, is that neutrons are really weird. So when we have these critical assemblies, we say a critical assembly like a DIVA, which is what we call a fast burst reactor. We have a bunch of noise come out, or we have a bunch of neutrons come out, and they can interfere with detectors. And specifically, when we're trying to measure neutrons, we can have weird anomalies within our detections. And so we want to get rid of those. But how do we do that when it's how do we do that? Currently, what we do is do post-processing, but it's really time consuming. And if we are in a scenario where we need to have results really quickly, whether it's like a criticality accident or any sort of incident, or maybe even just reactor monitoring, we want to be able to do that in real time. So what I'm trying to do is get real-time measurements from these neutron detection events and kind of figure out an algorithm to get rid of those strange little anomalies that give little noise and random peaks. So we can get an actual clear image of what the neutron spectrum within the detection event is, what it is. Yeah.
Mm-hmm. And you mentioned doing a couple of little experiments on this. What do some of those look like?
So I haven't started any of those yet. I am currently in the process of getting certified to go into, it's called our R cell. It's where we keep all of our radioactive sources. And they don't just let anybody in there. So I have to go through a whole training process. So I'm still kind of looking at what we can do. But we have like our deuterium tritium sources, depleted uranium, and probably just doing some basic measurements with some of our neutron detectors, maybe some like organic scintillators, and then I would like to see if we have some like anomalies within those detection events, and see if I can start building a kind of basic algorithm to get rid of those. But currently, right now, because I'm at Georgia Tech, I'm here for another year, and then I get to go to Los Alamos and do my research full time, which is a dream. I am so excited. We're kind of just there. Los Alamos' goal for me at Georgia Tech currently is to just learn how to use every single detector we have, and get to play around with stuff, which as someone who's an experimental physicist, I love. Because I once had a professor that made fun of experimentalists who were like, oh, they just play with toys in a lab. And it's like, yeah, if I'm doing science, I want to wear the white coat. I want to have my crazy setup. Like that sounds amazing. But yeah, so that's what I'll be doing.
Cool. That's so cool. And when you say putting together an algorithm like this, I'm imagining running a ton of experiments to try and understand kind of what those anomalies look like in a very general sense, and then having a computer kind of do that post-processing that you talked about for you. Is that the general idea? So
essentially, basically, we want to have a really good understanding of what these neutron spectrums are supposed to look like.
Right.
And that means in like multiple configurations, because like I can take data from a single neutron source over and over again and get a really good algorithm to kind of do the real-time neutron noise analysis. However, if we're in the field, or if we're during a criticality experiment, we might not have that perfect experimental setup. So I want to kind of take as much data as I possibly can with different configurations, different neutron sources at different depths and different detectors, and then be able to see like, okay, so this is what the neutron spectrum is supposed to look like with all of these, under all of these different circumstances, and try to see, the pattern there. And then from there, we can see everything else that's not supposed to be there that we've gotten from all of these, and then see how we can get rid of them. And then start with that kind of basic algorithm, sort of doing like machine learning, and kind of start training this system to detect them in real time. So that's kind of the premise of this. Obviously, this needs to be developed further, but that's kind of the fundamentals of it.
Yeah. What's and what is the application of not only the algorithm, but being able to remove this neutron noise in the field? You mentioned kind of criticality events and some issues with that, but what's the goal? What were we trying to do in the first place that this is a problem?
So like exactly, what is the point of it? So this was originally brought up to me by a few scientists I work with at Los Alamos, and it was for the Stacy Critical Assembly in Japan. And the Stacy Critical Assembly was originally created after Fukushima to kind of do debris analysis. And so that's ideally what we would be able to train on. Whether that happens or not depends on a lot of different factors. But basically, if we have an incident God forbid, anything like Fukushima or anything like that, we need to be able to know what spectrum we're getting really fast. And so basically it is to allow people who are in the field that are going to be dealing with this to know exactly the neutron dose or the neutron spectrum that they are encountering, which can help them identify exactly the kind of radioisotopes that are in the environment, and then be able to deal with that in an appropriate manner. Because obviously not all radioisotopes are made the same or created equally. So to know what you're dealing with can radically change how you approach the situation. And it can speed up response time, it can save lives. And that's kind of the goal, is to just make things easier for these like first response teams.
Very cool, very cool. And do you think over time, this is a little bit of a hypothetical situation, but over time, as power plant processes become more automated, people are sending in robots to do jobs that they used to be doing. Do you think that it's a combination of keeping people away when you can, and then having technologies like this for events where you do need to send in people that are going to make these processes safer?
Yeah, I think at the end of the day, all we want is to make nuclear energy as safe as possible. And nuclear energy is very safe, as we know. But
yeah, of course,
if we can do every single thing in our power to make sure that we are protecting the environment and people, then we have to do it. And that's kind of what I love about this project, is that I actually am going to see this project be used in real time to help people. And it's just so cool.
Yeah. Have you, so far in your career, or do you think in the next couple of years and while you're doing your work at Los Alamos, will you be working with people in the nuclear energy industry, or do you primarily work with other academics and government officials?
I hope that I get to work with people within the industry, not just like at power plants, but people doing, the small modular reactor startups. That's something that I'm interested in learning from people from all parts of the nuclear industry, because I feel like at times when I'm in academia, you're just surrounded by other people that are in academia, and you're like, this is I need to kind of branch out. And the same thing happens with national labs. You're just surrounded by people who work for the National Lab Complex. And I think it's important to kind of branch out and talk to everyone, because one, that's kind of how innovation is made. And two, that's how you learn. Because everything that I can learn at a national lab, and which I can learn a ton, I can learn more if I'm talking to people outside of where I'm working.
Right.
Yeah.
Yeah. Do you have kind of a view of the nuclear energy industry from your vantage point outside of it, that motivates your research, or is it kind of a purely academic, like, this project is interesting to me and I want to solve this particular problem? Does that make sense?
Yeah, so that's a really good question. No, I genuinely, when I first started, I was very much a physicist and was like, I want to do the fundamental science, and I want to get into the nitty gritty of, like, even approaching the policy stuff. I was like, I want to do it from like a very academic perspective. However, when you're in nuclear, you can't have that perspective, because a lot of people are talking about how we're on the verge of this nuclear renaissance, and I'm very hesitant to agree with that or to use those terms, because it would be amazing if this is like a nuclear renaissance and we see nuclear energy expanded, but the way we do that is by talking about it. And so you can't take a kind of passive role when you're a nuclear engineer. You have to be out and willing to talk to people. And there are like so many ways to do that, whether that's just like interacting with other people in the industry, taking a vested interest in, I'm not a reactors person, but I am constantly reading about the Vogtle power plants in Georgia, because I just think that that's like such an important thing to do as a nuclear engineer. I think that's what's going to actually be what propels the industry forward and propels nuclear energy forward, is if we start taking a more active role as kind of spokespeople of nuclear energy.
Very cool. And how do you think the nuclear energy industry is going to change over the next couple decades? Maybe not decades, let's say 5 to 10 years. Ideally informed by the research that you and people like you are doing. Do you have what's coming?
Yeah, there is so much coming, and it's so exciting. So I'm not a reactor person, as I said, but the small
Yes.
modular reactors that are coming online and slowly making their way through the NRC. But in order for nuclear energy to be successful, we have to change public perspective because a lot of people are afraid of nuclear energy. And we, as nuclear engineers, are kind of at in a difficult spot because, one, we want people to be afraid of nuclear weapons, but we don't want people to be afraid of nuclear energy. So how do we approach this kind of separating nuclear energy from nuclear weapons? Because I know people that, like my roommates, who are also getting PhDs, had no idea how a nuclear reactor worked.
Mm-hmm.
And so after explaining it to them, they're like, "Oh, really? That's it?" And I think the way that we're going to do that is not just by the technology that is being created, but it is by the people that are talking. And there's a lot of young people in my generation that are starting to really develop platforms. Miss America is a perfect example of someone who's young, who's going around the country and talking. There's also people on TikTok. Kaylee Cunningham, who is an MIT graduate student, has this TikTok account where she just talks about the myths of nuclear energy that people have, and she'll respond to people's comments where they're like, well, what about nuclear waste and how bad it is? And she'll be like, no, this is what actually is going on. And she has a big following, and it like pops up on my For You page, it pops up on my like friends who have nothing to do with nuclear. And like that's how we're going to change and grow, is by people like Miss America, Grace Donkey, and Kaylee Cunningham. And like even not even just those people that have giant platforms, but talking to your family at Thanksgiving. And that's something that I'm notorious for doing. If I am in a group of people that don't know about anything about nuclear, I'm going to be so annoying because everybody is going to leave there understanding that nuclear energy is clean energy. And even if they don't want to hear it, it makes Thanksgiving so much fun for me.
Sure. Yeah.
But like we need to keep doing that. And I think I see a lot of young people starting to do that more and taking more vested interest in growing this community, and it's amazing.
Yeah, I am the exact same way at my own Thanksgivings. But yes, and it's tricky, I think, as a scientist in particular, because, and particularly as an engineer working on these systems, your job is to think of all the ways that things could go badly and say, here's how, and be talking about that and saying, we need to figure out solutions just in case, and then turn around and be able to communicate to the general public and to audiences that just because we're preparing for things doesn't mean that they are even close to likely. And that's been a tricky one for me, I think. But
yeah, especially with like Oppenheimer coming out.
Yes.
That has actually been Oppenheimer. I love that it came out. I actually saw it when I was working at Los Alamos. I sat next to somebody who was in the movie as an extra.
Oh, wow.
And that was like so neat, but it like kind of started a conversation because, my friends and people I went to high school with have me on LinkedIn. They see that I work at Los Alamos, and then they start wanting to have a conversation with me. And a lot of times they approach it really aggressively of like, how could you work at this lab that did this thing? And it's like, yeah, okay, let's talk about it. Let's like have a conversation. What are you afraid of? Let's like, I want to know what you're thinking, because not only is like, it's not only important for us to be talking to people, but we need to be listening to what the public is thinking, because it's the only way we're going to understand them.
Yeah, absolutely. And I want to shift the focus a little bit to kind of the academic world, and people working on nuclear energy. As part of this series on young people in nuclear, would like to know, what do you think our generation has to kind of offer this field, and how do you think people our age are going to change it?
Something that I love about this generation is that we are so intense about climate change. I think we all are kind of aware of the climate crisis, and have kind of taken it upon ourselves to be like, okay, we are the new stewards of this earth. And what are we going to do to save it and make it better for future generations? And so I think like with our generation and these young people that I get to talk to all the time, we just have a lot of, not anger, but we have a lot of passion for what the future is going to look like. And we are kind of at the precipice where we're the ones that are starting to make the decisions, or about to start making the decisions. And so you see all of these young people that are very into advocacy. And I think that not even just with nuclear, but in general, that's kind of how we're going to propel ourselves forward, because we care about each other a little bit more. That might be, I'm assume that somebody that is in a older generation is going to hear this and be like, these youngins don't know anything. But like I don't know, I think we are more open and like interested in, trying to push society forward and, even with equality. And yeah, I think that's a bad way of kind of explaining it, but yeah.
I think there's something to the forced connectivity of, frankly, the internet and how exposed we've been to so many more different people and online presences that has made us a lot more aware of the community around us.
And like, sometimes I'm like TikTok, like the internet and how connected everything is like a curse. But at the end of the day, it helps so much because like there are so many things that have made national news or people have become aware of because of the internet that in previous generations would have gone completely unnoticed and not talked about.
Mm-hmm.
And so we're able to kind of put more energy into these issues than we have ever before. And that's really cool.
Yeah. And it's nuclear energy is one of those topics of conversation that I think has seen, to borrow your word from earlier, a renaissance because of the internet and the way that young people use it. So that's really interesting. I got a couple of personal questions. What are you most proud of accomplishing so far in your career?
Oh man. Well, I never thought that I would go to grad school. So, I mean, going to grad school has been an amazing experience, honestly. So I am part of this group. It's called the Nuclear Engineering Student Delegation. And it is a group of nuclear engineering students or people that are interested in nuclear engineering, typically graduate students, that meet in Washington for a week and go talk to different legislators and the White House about nuclear energy. And I have wanted to be part of this group for a couple of years. And my mentor at Los Alamos was actually a former chair of it and really pushed me to do it. And I interviewed, didn't think I was going to get it, and then got in. And actually next week I go to Washington, and to be a part of something like that, where I know that I get to actually be face to face with people who are making the laws that will affect nuclear energy, is amazing. There's a lot of times that I stop and think like, how did I get here? But I don't know. I think overall, coming from someone who went to a community college, I started my community college career in Algebra 2. So, that's something you learn in freshman or sophomore high school. And I was in college learning that. And now I'm getting a PhD in nuclear engineering. Like, I'm not supposed to be here. Mm-hmm. Like, I'm really not. And so I guess that's the really what I'm proudest of, is that I get to do what I love, but also still get to teach people. And
That's great. And we're glad that you're doing the research that you're doing. That's important work. What, looking forward, and goodness knows I don't have this figured out either, but what do you think is next for you? Are you aiming for lifelong research, or do you want to try other things?
I switch back and forth on this all the time. I know that I want to remain active in nuclear policy. It's something that I'm really passionate about. It's something that I think I'm relatively good at doing. I love reading all of the really boring documents because they're not boring to me. And I would love to continue doing that. However, I also love the research aspect of it. And what I'm currently hoping is that I get to continue working for Los Alamos National Laboratory, because that is kind of the perfect intersection of being able to work on policy while also working on some fundamental experimental science, and while doing stuff that like actually matters. And that's kind of what I am hoping for in the future, is national lab route. Hopefully Los Alamos, if they hire me.
Very cool. And good luck. Any particular research areas of interest that you want to check off your bucket list at some point?
Gosh, I know I want to stay in non-proliferation. That is, I think, in my opinion, the most interesting. I think it's the most dynamic as well. It's constantly changing. Not research interest, but I would love to just be able to actually help formulate policy and have actual input and be like, no, this is like, be able to advise people who are actually writing the policy and be like, this is what you actually should do. And here's the evidence and the research and data to back it up. I don't know. I would love to see where I can go with that. But
yeah, it's really interesting to see when you can take an experiment and then actually have it inform the way that we regulate something like nuclear. So that's very cool.
That's like the policy is what really affects us day to day.
Mhm.
And I don't know, a lot of times, sometimes I watch the news and I hear some of our elected officials talk, and I'm like, oh, someone needs to talk to your advisors, because that is so wrong.
Yeah.
And there's a lot of fear mongering out there, especially for nuclear energy.
Mhm.
And it's got to stop. And so I would like to be part of that change. To stop fear mongering and just give facts and data, and in a way that everybody can understand, so people aren't so afraid.
Yeah. Communication is half of changing minds and making sure that science actually makes it all the way to the public. So
It really is, yeah.
yeah. And then and see that we're getting towards the end of our time, and I want to end on a fun note. So let's say what advice would you give to someone who's interested in nuclear energy and wants to do research in a lab the way that you are? Like, how would you advise them to get off the ground?
The way I did it was by trying everything. So I got really involved in extracurriculars. I would say the worst thing you could do is just go to class and that's it. Obviously, classes are important. Do well in classes and all that. But I think really when I have learned the most is when I have been outside of the classroom. So I was A&S president at my college this past year, and just being able to, I learned a ton about nuclear energy just by interacting with people that I was inviting in to speak at events, or we had the NRC chair come and I got to have lunch with him. And how I got in contact with you guys is just by being around and just saying yes to opportunities when they arise. And that's every single time that I have been able to do something incredible, it's because I just said yes to something random, and it's just kind of grown into this amazing thing. And so you really don't know where these small little opportunities are going to take you. So I would just say yes to as many opportunities as possible.
That's great advice. Thank you. And thank you so much for joining us for this conversation today. We're really glad to talk to you.
Thank you for having me. This was so much fun.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.